Let's do a second challenging piece to this cliff problem here. Let's answer the question: what is the final velocity of the ball? Now, should it be faster or should it be slower or should it be the same when it ends? Well, if you think about it, this ball was going horizontally at 5 meters per second with no y component, so it was really just could be described as 5 meters per second. But it's also picking up speed in the downward direction. So at some point, we're going to have one of our triangles here. The ball continues to go 5 meters per second. It's going to pick up speed in this downward direction. We're going to figure out what that's going to be. And then those are going to add together to give us a resultant speed that's actually faster than what it was before. So all we have to really do is go to our linear motion formulas to find velocity with acceleration. So the final velocity is equal to the initial velocity plus acceleration times time. In this case, our initial velocity is 0, and it's going to be in the y direction. And acceleration is gravity. So this thing's going to go away. And I'm going to work to the right here. So my final velocity in the y direction is equal to 9.81 meters per second squared. We've already calculated our time at 0.64 seconds. So 9.81 times 0.64, I get 6.3. One of those seconds goes away, one of these goes away, meters per second. Now I know how fast that thing is going when it hits the ground in the vertical direction. And now it's really just a Pythagorean theorem. And I can say, let's make this the resultant vector. We'll make this x and we'll make this y. The resultant squared is equal to x squared plus y squared. Okay, so let's just go ahead and say square root, or r, is going to be equal to the square root of x squared plus y squared. And we'll substitute in there, and we use 5 meters per second, quantity squared, plus 6.3 meters per second, quantity squared. Let's go ahead and do that work. So 6.3 squared plus 5 squared equals, take the square root, and we get that the final velocity is 8.04, so we'll call it 8.0 meters per second. So that ball picks up speed and actually ends up going at an angle into the ground at 8 meters per second. So one more little piece of the puzzle there in solving a problem.